Welcome. How are you? We're gonna get into our first chapter today. I'm gonna be doing some demo with the programmer, the IDE, Integrated Development Environment, and the one we're using is NetBeans. And when NetBeans first starts up, we have the option of creating a project. So we're going to go to File, New Project. This is going to give us our code files. And we're going to go with Java with Ant and a Java application. This is going to give us a standard Java application. Put it on your desktop and give it a meaningful name. We'll call it Chapter 1 PPT. And no, that's good. Create main class is going to create a main for us. Okay, there's our main. By the way, you can hit Control. I think Control and the mouse. Oh, it's Alt on the mouse wheel to increase the size of that. And this is where everything begins. This is where main starts programming. Our runtime starts here in main. It's the function that begins everything. It's what's called when our process asks for RAM and begins. And so our entry point to do anything for our application is in main. It starts here at the beginning of this brace and ends here at this closing brace. Now, since Java is hyper-object aware, there's only one main, but everything has to be in an object, even main itself as a function. So it's got a wrapper function or wrapper object that really kind of is just a wrapper. But inside of it, you have your static main, and so this object right here, this is just a hold. It's just a box to hold main. That's all it is, and you don't use it other than doing your code inside of a main. You will include other objects, and you will use other namespace packages. And so that's what this is for namespacing. Your code is put into a special box. And in that box, you have other objects that can be inside of it. And you have to open up that package. And inside of it would be the code files that are for that particular protected namespace, which is what packages are for. And that's just because the tool chain that we use when we're programming starts with somebody else's code that wrote something for us to use. All right. So the focus of the course is, of course, object-oriented programming. We're going to be starting from the bottom and kind of building up awareness as we progress. The main thing that allows Java to be successful is its implementation of the objects in the way that polymorphism and inheritance works with what is called dynamic binding. Dynamic binding is something further down that you will get to once awareness of polymorphism and inheritance is a little bit more clear. Right now we're going to be having objects that we create, and inside of an object can be primitive data types. But the thing is here, guys, is everything's a number, no matter what. It doesn't matter what it is, it's a number. So it always comes down to a value, mostly an integer, a double, or a float for your data types. And some of the stuff, guys, a lot of you guys already know. One of the main things that I wanted to get into was the binary numbers and data types. Give you a little bit of a preview of what is meant when we're working with data types, because again, everything's a number. You can pick out a pixel on your screen, zoom in, get the red, blue, green value for it as a number, get the location where the pixel is located at as a number, and then build the tools needed to put that on the screen as a color image using the hardware. And so we're on the software side, and a lot of what we do is dependent on one main disadvantage, one main constraint. And that is because the CPU, and yep. The whiteboard's coming out. Sorry, it's coming out. It's coming out. It's coming out. Okay, let me clear you up. You're going away. All right. We were talking about what were we talking about here before? Data types and everything being a number, and what those numbers are and how they're represented, all that good stuff. So when you're working with binary, especially when we're thinking about data types, since everything comes down to a number, we're going to start with just what is binary. Binary is a two placement. It does not have more than two characters. So how do we represent the value 9 with just ones and zeros? And the answer is just you have more of them. you just have more of them. You know, I give elementary students, hey, these are the only characters you can use, 1 and 0. And I said, represent 9 with a 1 and a 0. And they would throw in 9 ones. and it equates over to our number system. Where we have a placement, and in that placement, we count the value of that placement within wherever that bit's set. So a bit is a single 0 or a single 1. That's what a bit is. And when we have a byte is 8 of those together. So how do you count in binary? Let's say that we have the number 0, 1, 0, 1. We put that up in the placement section that doubles every time for every placement. Remember, we have more of them because we're doing elementary math here. This is 64, and then we got 128. And so we say 1, 0, 1, and then we look at the placement, and that's what we count up to get its value. 4 plus 1 is equal to 5. So we add the 4, we add the 1. We don't add the 2 because there's no 1 there. And so we know that 1, 0, 1 is equal to 5 in decimal. Just normal 5. And so that's what it works. And each placement doubles. So you see some numbers that you kind of recognize here. 32 gigabytes of RAM, blah, 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 blah. Yeah. That's how binary is done. But guys, let's not be primitive. Get the whiteboard out of my face. There we go. Let's get our calculator up. Go up here and you can just choose whether you want standard. This is probably the way it'll pop up for you. But pretty much all standard, main calculators on operating systems come up with the ability for you to go to different types of modes. And you can go to the programmer mode, and you can go to the bitwise bit toggling, and you can see here that here's 1 bit. Okay, 1 bit set to 1 is 1. 2 bits set to 1 is 3. 1 bit on the side set to 1 is 2. That one is 6. That's 5. And so you can go all the way up to some really large numbers represented in binary. And you can kind of get a feel for it using this tool. It's kind of cool. Well, how does that equate to binary or to data types? Well, everything on the computer is a number, but we have different types of numbers, and numbers have to have some limitations because we are on a finite machine, so we give numbers limitations. But let's come up with, I'm just going to come up with an imaginary number and kind of explain data type ranges. And it's directly equated to the data type itself and how large and how many bytes it can be stored in RAM. So a regular integer, a short integer is 2 bytes. Has 2 bytes. 2 bytes. A short integer has 2 bytes. That means it's got 16 bits in it. 16 of those in the programmer. So 2 bytes. What's a short integer? Let's go get the calculator up. That's 2 bytes. That's 1 byte. That's 2 bytes. The largest number a short integer can store, it can store 0 to let's go all the way out. The highest value you can store is 6535. But here's the thing, is short integers, if it's unsigned, it can be stored, the numbers 0 to 65,535 can be stored in that variable. But if we make it signed, that means we flip a bit on the end. And that becomes a minus or a plus bit. And now it becomes negative 32,767 or 766 to 32,767 or 768, whatever. There's a fence post in there. So we change that variable to being assigned, but it can now represent negative values. That's how data works at the lowest level on a system, on a computer. And let's pretend that we are creating a 4-bit variable. It's only 4 bits. That means it has 4 zeros it can store. And it has the ability to store 4 ones. So that means its range is it only has 4 bits. So its range is 0 to 15. So 4 bits can only store 16 values. And you see these numbers, 16, 32, 64, 128, 256, 512, 1024, 2048, what's the next one? Yeah, whatever. That's how data types are represented on the computer in different ways. Some of them are just Booleans, where it's just a 0 or a 1. And this data type we call a Boolean. Then we have the char data types that take up 1 byte that represent an ASCII code character on the keyboard. But let's get back into, we've gone off a little bit. Let's see what else is good to cover. There we go. We kind of talked about that, the range of values, the permutations you can play with in the thing. Permutations, that means, just 4 bits. Hey, it can store up to 15, and these are the permutations. It can store up to 15, all ones in the 4 bits, or it can store from 0 to 15, and whatever permutation in between. All right, let's see, what else we got? This is stuff main memory. Okay, this is a good one. When a process starts up, And I'm not really talking about your process. I'm talking about the back end, the middle language, the middle process that is running the JDK program. When it starts up, it asks the operating system for RAM as part of the process. Now it passes that on to you, so you get automatic RAM available to you from what's called the stack, and that's what's given to the process or the processes. And you are given memory on the stack that you can use, but it's very regimented memory. Memory on the stack. The stack is given to your process to use, and every variable you declare goes on to the stack. Every function you call goes on to the call stack, and there's a way to view the call stack. We'll have to come into that, and I'll show you how to do that. But that memory is automatically given to the process, and we call those automatic variables. And those are the type of variables you're going to be working with mostly. And those are the primitive data types: integers, floats, doubles, chars, whatever. Now, then there is all the other memory available that the operating system has that can be asked for, and we call that the heap. The heap is just the rest of the RAM available because we automatically get this memory. We don't have to ask for it. We get it as part of the process. And then we implicitly use it when we define and work with data types. The heap is all the other memory out there, and we usually use that with non-primitive data types and the new statement, where we ask the operating system for the first block, the first binary block, or the first address, memory address of a block of memory that we can use. And if we need it for a scanner, we say equals new scanner, that sort of stuff, where we're creating and instantiating objects where we need to ask for memory. That is what comes from the heap. And Java's nice, and it's not like C++ where you have to delete memory that you asked for from the heap when your process is running. It'll automatically look for that at the I want to say interpreter, but that's very loose, guys. It's not really. I'm going to call it the middle language. The middle language is always looking for if any memory that you created goes out of scope, meaning you created memory in a function. The function starts and ends. You come out of the function, and then this memory you created comes off of the heap automatically with the garbage collector that's going on behind the scenes at the middle language level, the interpreter. It's not really an interpreter. It's very loose. That's very loose. It's a hybrid. So when I say interpreter, know that I'm being a little cavalier. All right. That's stack and heap memory. That's the RAM that you use as you're programming is important. So you're going to start out with automatic memory that's assigned to you, and memory starts at 0 and ends to how much you have. So if you've got 64 gigabytes of memory, the addresses start at 0 and then go to 1 and then 2 and then 3 and then 4 and on, all the way to how much megabytes of memory you have. Every byte has an address, and that's what we have memory tests for, is make sure that memory is correctly contiguous, because we use the memory contiguously. So if one block is bad from another block, that's not good, because we'll ask for 4 bytes. We'll get the 4 bytes that starts at this memory location, and what about the next 2 bytes? What if the next 2 bytes is bad? So a lot of that's going on behind the scenes. But the idea is when you're working with memory, it's linear. It starts from 0 on up, and it's per bit. It's granular. So the addresses are contiguous. And when you ask for memory, you can ask for an array a static or an array that gives you a contiguous block of memory that you use per numerical continuous address. You see how they're numbered as you go down. So a lot of the memory that you ask for is going to be dependent on that. No, actually, no, not a lot. All the memory. So either this is on the stack, or where you don't have to ask for it, you can just use it, but you got to be aware that it's linear. Or this same thing is over here on the heap, and you ask for those bytes, and you keep a reference to it in a pointer. So everything in Java is a pointer. I'll probably be talking more of that as we progress. But storage capacity, this sort of stuff, I'm not going to get into. This is stuff that is not really too much into the meat of things. All right, now we're into it. All right, the programming language itself. And it was created by Gosling. Gosling created it at Sun Microsystems, and it was purposefully engineered as a hybrid that is hyper object oriented, meaning dynamic binding is part of the native language. And that's what makes this stuff possible. Dynamic binding is what makes graphical applications that you can use easily possible, guys. It's the only thing that makes it possible. That is not an old school like Microsoft MSC classes where you had to build the GUI yourself. So now you can be gifted this stuff at a base level with inheritance and dynamic binding. Keep that in mind as we're learning more about this programming language and its implementation, and like C# and some of these other ones, is what gives most people the keys to an easily, rapidly graphical user interface, or developed graphical user interface. And that's because of the dynamic binding and how objects build on top of each other and how they're boxed. They box in all as, everything's the same data type. Everything's an object in Java, no matter what it is. It can be a printer. It could be another object that represents a spectrometer. But they're all numbers. They're just nice and clever arrangements of your numbers. So let's talk about how that clever arrangement begins. It begins with what we call a class, or a way of managing things. This example of a class is not a very good example because this is static. There's only one object that main can be inside of. So this is just kind of a dummy wrapper, because Java is so object aware, of course, that even main, the starting point of the program, has to be in the object. And I love this nice little static here, meaning there's only one main possible. Well, duh, if you're building a program, there's only one starting entry point to the program, and that's main. And this is very C basic. This is just like C++ and C. And then you got default arguments that you can send main, such as maybe directories to open a file when the program opens and starts, where you can set up so that you double click on a .dat file and it automatically runs your program and sends the arguments over for the file that it needs to open on start, and that comes in as args, and you just open a file and do what you need to. That's your input. There's a whole operating system called Unix and Linux and OS X that's based on nothing but C and C++ code that works together by calling main and sending arguments back and forth. Yes, it's freaking nutty. So you're in that world now a little bit. Not totally in there, but a little bit. All right, let's talk about the structure. This is just a wrapper. So the main thing is this guy right here. We say we have a main entry point. We have arguments. This is the start of the runtime code that does something. This is the end of the runtime code that does something. And what I mean by starting point is that your program enters right here and exits right here. So let's look at that. I'm going to copy and paste this. Now I want to point out some dangers because I'm actually copying and pasting this from PowerPoint. When you take code from another application or file type or whatever, sometimes what will actually end up happening is you copy Unicode that comes with it, and that is code that you don't see behind the scenes or the editor doesn't show. So it's always kind of dangerous to copy and paste from a website or whatever, because you could have Unicode characters in there that the editor doesn't show you. So the editor is only designed to show you text at the ASCII standard code. If you take something from a website or a high-level markup language like a PowerPoint text and you paste it in here, it could have the markup language in just printing that in behind the scenes, and the editor is just, you know, weird things happen, guys. Weird things happen when you do that. So you got to kind of make sure that sometimes what I do is I get the text and I will delete every white space, because it's always, you know, the white space that's going to be the nightmare when you grab code from you know, something else. So be careful with that. That has ruined my entire week sometimes, because you can't see it. The editor won't show you the Unicode. Some of them won't. Let's see, does it have any problems with this one? Let's go up here to the hammer and just do a build without running. Okay, so that's what I did. Is down here is this window pops up. I hit the clean and rebuild. The clean cleans out files from the previous build when you prepare it for the back end, the middle language, the intermediate language. To be, you know, walked by the interpreter. So let's set a breakpoint so that we can view what's going on and look at the flow of the program. Because when I talk about flow, I'm going to be talking about how the program moves, the logic, what it does, how it does it, syntax and semantics. Syntax, what you write. Semantics is how you write it. What direction of the flow do you write it in? So I'm going to set a breakpoint right here, and I'm going to go up here. I'm going to go up here to this debug, so that it runs. It'll prepare it for the middle language, and then it'll run and it'll stop the process right there, so that we can see what's going on. And it hasn't run this line yet. So if we go out down here, we're in debug mode now. We can see variables that have been declared on the stack that are assigned to our process. We can actually add variables from the stack or variables in here to look at. And then, of course, you know, remove some of this stuff that's in here from previous stuff. I can just kind of select them. These are little watches that I look at variables when I'm running a program, and it loads up the variables, loads up some of the automatic variables, like the arguments that come in. You can send arguments to main, that'll come in right here, and you'll see it, and you can logically make decisions based on what it sends you. So a program can start another program. That's, yeah. And we have a return value that you want to give. In this case, Java isn't done that way. It's meant to be on top of operating systems. Okay, not embedded in operating systems. So like C or C++. I'm talking Unix, Linux, that sort of thing. All right, so the program stopped here. As soon as I do a step over up here in my debugging, I can do I think an F10 or an F11 for a step over. Oh no, in NetBeans it's F8. Excuse me. So I push F8 and I step over. That line just ran. That line just ran. Line 14 just ran. And I can go over here to output, and you see right here at output, This is the screenshot area where I want you to screenshot your output so you can show me your program ran. Then right there. Then it completes and it's done. So the starting point was here, the ending point was here. I'm going to be using the debugger in my talks quite a bit, guys, because if you're not doing this, you're not learning to program. You're just playing. So don't depend on outputs for your debugging, just checking what happens as it goes. Just don't. Embrace it, because this is programming. If you embrace debugging, you're going to be able to master every language out there. That's it. Learn a C-based language. That's what this is. Master debugging. You know them all. Simple. All right. That's runtime flow. I showed you how we can pause it and step over and look at it. And so that's the very starting point of a Java program. And remember, this class here, we're going to be talking about classes as we progress. This is just a wrapper right now. It's just a container that holds main. We're going to be building our own containers. All right, and those containers contain declarations, like you see here, definitions of a Java object. You're going to define a box that you're going to call my program and put things inside of it. And those things will be just primitive data types. Remember, everything's a number. So we put the data types in here that we want to use for this object, and you can think of the object itself as the program. And then we can drive that program from main. We drive it from main. We define it, we instantiate it, and then we run it and work with it. So when we declare or define an object, it starts with the object name, what it's going to be, the class keyword, excuse me, and then the object name and the object name, you want it to represent what the object's purpose is. And then we're going to have public access. So that means that somebody that wants to use this object that is out of the scope that I give the object to use within main has access to it. So I can access an instantiation of this class from main out of scope. And I'm going to be talking about scope because scope is where you create variables. They live and they die by your runtime. And you just define a variable, integer I, and that comes from your stack, your automatic variable. So we call this an automatic variable. And it only lives and goes on the stack when the entry point comes in, your flow goes down, and then it exits. So let's look at that. Okay. Let's change this so that we're setting the breakpoint here. Let's do this, I equals 0, I equals 5. Get a little bit more of a clear, because debuggers don't like to stop when you're defining things. They only like to stop when you're doing something. So I'm just going to go over here and then set a breakpoint. So that's why you would have a problem setting a breakpoint right here, because it's defining something. You can only debug with actions. So when it actually happens, then you can catch that with the debugger. So that's why I can't really set a breakpoint there, because I'm saying in I, that's a definition. But the equals 0, the debugger likes, because that's what it does. It's the action part of your program. This is defining things that you're going to use, declaring them, and they come from the stack that's given to your process. And we call those automatic variables. And you see those in the debugger. So look at this. Okay, so the program has stopped. Has it stopped? I think right here, yeah, because there's the green bar. Look down here, you see I. It's 0. Okay, when I do a step over, there, now my runtime is here. And I has already been set to 5, and look down here. My automatic variable was set to 5. And that's working with the stack. Every function call, every variable goes on the stack. What goes on the stack is the living entry of the beginning of your program and what it does. Stack, 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 stack. Programs off, comes off. Function calls come out. Off the stack, off the stack, off the stack. And program's done. All right. That's getting, we got a little on the detailed side. So remember, this is definition code. This is not runtime code. We're just defining what the box is called. This is definition code, the wrapper that's going to hold main. Every object has the ability to hold variables within its scope. So we can put variables in here that main would use at the application level. We would also include libraries and instantiate our own objects down in here. So the entry point begins with main that has to be wrapped into a class. So your runtime starts here for logic or for Java. And then we can, add variables for the main if we want. And so what ends up happening is our whole program is an object, which is the way I've been writing C for a while. Every program I create, I just make into an object, and then I have objects inside of that. So it's kind of a nice way to do it. All right, where are we at? Ooh, no, don't want news. Okay. Comments, good. You guys can figure that out. Identifiers, this is names you give variables. Guys, it's case sensitive. It cannot start with a number. You cannot start a variable name with a number. You cannot say I integer 5i or 6i. You can't do that. You can do I6. But the reason why is because for every compiler, interpreter out there, there's no way to determine that this is the number 6 or the variable 6i. So there's rules that need to be followed, and that's what this is. It talks about the case sensitivity, use of different variable types and special dollar signs. I want you to adhere to what you decided when you did the research on the quality code discussion, and from what you got from your peers, that that is something you want to adopt personally and implement it within this rule set. Okay, keywords are just most words of this nature. Every programming language out there uses mostly, or some flavor of it. All right, I think I've given you some of the meat, and we got some other stuff out here that you can get in with your reading, some of the details, and then of course we've got your first application built. So remember, I'm wanting your code in a document, copy and paste it as text, and then give me a screenshot of your output showing that it works. That's kind of what I'm looking for. Well, that is what I'm looking for. So I'll demo it. Word. If this was my program and I wanted to submit it, I would of course label it, but at the very minimum, I would have my code, all of it, multiple code. You can do the screenshots above or below, but you can put the code as text. It has to be as text, guys. And then you're going to take, and you can use Snippy. You can run this. I'm just going to run the previous version of it. And then, okay, whatever. You want to be a naughty boy, I'll let you be a naughty boy. Okay. So this is what you're turning in, this program. We just pasted the code in. And then, oh geez, oh the dang thing breaks. There we go. Okay, there. See that output right there? That's what we're gonna screenshot. We're gonna grab little Snippy over here, who's on pretty much every thing. We're gonna say new, and then we're gonna select that. Okay, and then it's already on the clipboard, so we can just go right over to Word or whatever you're using, and paste it above, below, whatever. Label it, label, please, and then oh, it looks like I tried to do Control V paste here, but it looks like it didn't copy, so I'm gonna have to go back and redo that. Let's see, Snippy. I don't think it went on the clipboard for some reason. Maybe because I didn't. New. Okay, select it. Oh, okay, you have to copy it from here. Okay, that makes sense. Yeah. All right, so it doesn't automatically put it on the clipboard. Okay. There we go. That's the screenshot. Then the text is code. Okay, guys? All right, happy trails. We got your first program done. Little demos, and we are ready to move on to some other fun. And I will see you later for that. Thanks.